Myself, Ketan Patel from Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI, Electrical Engineering Department. Subject is Switchgear and Protections, 4th year, 7th semester. Chapter number 4, Transformer Protections. Syllabus content. First is transformer faults, overall protections of transformer, percentage differential protection for transformer, Merz price protection for power transformer, difficulties in differential protections in transformer, protection against in magnetizing induced current in transformer, and core balance type earth fault protection in transformers. Now, first, transformer faults. First, we discuss about the basic details of transformer. Transformers is a static device and is a simple construction. Protection of power transformer is relatively simple compared to protections of the other equipments. Merz price protections, Foucault's relay, etc. are included in protection of power transformer. So, in this sections, we shall study some circuits used for the protections of power transformers. Different types of faults occur in power transformer. First, overheating of the core. The causes of occurring these types of fault and their effects are: transformer core gets overheated due to excessive loading, failure of the cooling system, or fault in the core, like a shorting of laminations. Due to this, the life of the insulation is reduced, and so the life of transformer is reduced. Second is improper contacts on the tap changer. Arcing occurs and the insulation is damaged when the contacts of the tap changer are not proper. In third one, failure of the cooling system. Cooling is affected when cooling fan stops working or there is a fault in the circulating systems. Due to this, the temperature of the core and winding increases, which affects the insulations. There is possibility of explosion or fire. And face-to-face fault and earth fault are also occur in transformer faults during some faults. In internal fault, the face-to-face fault and earth fault and internal fault can result due to the defect in the insulations. Excessive current flow due to this fault and further damage results. Possibilities of internal fault is less. If some turns of the same winding are shorted, the current increases and heating also increases. This causes unbalanced loading also. In overload, rate of heating increases when the load on transformer increases, so the winding and its insulation is damaged. And overvoltage, insulation get punctured due to the overvoltage caused by surges. Due to this, other faults can result. Okay, so these are the number of faults occur in transformers. Now we discuss about the protections of different types of fault in transformers. First is overcurrent protection of transformers. Transformer is connected in star delta. Cities are connected in the primary lines. Overcurrent relay 1 and relay 2 is connected in two phases. Okay, these are the 3-phase transformers. These are the star connections. Okay, and other side is delta connections. In star side connection, the 3 cities are connected in the star side connections. Okay, and the other cities are connected in these sides. Okay, these are connected with the help of the relay. These are the two relays are used. First is overcurrent relay and second is restricted earth fault relay. And this area is restricted earth fault protections scheme with the help of the overcurrent relay. Okay, these are the earthing fault. So cities are connected in primary lines. Overcurrent relay 1 and relay 2 is connected in two phase. Okay, and third third 1, 2 and 3 relay. Okay, and third relay is connected to star side, or we can say earthing side. The relay 3 is connected across the star point of the overcurrent relay and the earth. Overcurrent relay 1 and 2, okay, operates when there is a phase-to-phase fault or when there is an overload, and relay 3 is operate in case of the earth fault. Similar protections can be given in the secondary winding also. Okay, this type of protection is used for primary protections of small transformer and backup protection of large transformers. This is the basics circuit of overcurrent protections of transformer. Now we discuss about the percentage differential protections for power transformers. Okay, these are the star side and this delta sides. Okay, this connection is star side, star connection, and this is delta connections. Okay, and this is the protective device, CT, sensing device or protection device, CT connected to in series. Okay, star connected cities and delta connected cities, and these windings is star and delta windings of power transformer. Okay, and this CT connected with the help of the restraining coil. Okay, these 3 relay coil are restraining coil, and this coil is operating coil. Okay, so this is a relay, okay, percentage differential relay. So it's called percentage differential protection for power transformer. Okay, the differential protection scheme is used for the protection of transformer having rating of 5 MVA and above against internal phase-to-phase and phase-to-earth fault protections. The basic principle of operations of differential relay is that the vector difference of 2 or more similar electrical quantities like current or voltage goes beyond the specified or the set value, then the relay will operate, otherwise the relay will not operate. Okay? The primary winding of transformer is connected in star and cities on that side, they are connected in delta. The secondary winding transformer is connected in delta, and the cities on that side are connected in star. They prevent the out of balance current flowing through the relay coil due to the phase displacement between the primary and secondary in the healthy conditions. The restraining coil is connected in the pilot wires. The operating coils are connected between the midpoints of the restraining coil and the neutral pilot wire. Current increases to high value when the transformer feeds the fault outside in the protected zone. The differential currents flow if the characteristics of CT are not identical. But in the case of restraining current also increases, so the relay cannot operate. But when there is an internal fault in transformer, the differential current increases and the relay operates. The differential protections of transformer is also known as Merz price protections for the transformers. Okay. In Merz price protections for power transformer, also protection of power transformer. Okay. This is star side and this is delta side, and these are the cities for star connected, and this is cities for delta connected. Okay, this is a circuit breaker in both sides. This is strip coil connected to these contacts, and this is again strip coil. Okay, and these are the relay. Okay, relay operating coil. Okay, and this balancing resistors, this overload fuses. Okay, this is the pilot wire, and these are the quick fuse. Okay. In Merz price protection systems can be used to give protection against the phase-to-phase and phase-to-earth fault in power transformers. Such schemes for the delta star connected of power transformers. The primary windings of transformer are connected in delta, and the cities connected to that side are connected to star. The secondary winding of transformer is connected in star, and the cities on that side are connected in delta. Relay is connected is this. Kick fuses are connected across the relay coils. No unbalanced current flow through the relay as the secondary winding currents of CT are balanced. The initial interest of magnetizing current taken by the transformer when it is switched on passes through the quick fuses so that the relay cannot operate. The current balance is disturbed when there is an internal fault in transformer. The fuse blow off when the current passes through them for some period, and the current flow through the relay coil and the circuit breaker is tripped. Okay, there is only one difficulty in this type of protection, which was discussed in the beginning. Large current flow through the winding when the transformer feeds the fault outside its protection zone. The out of balance current flow and the relay operates in the saturation characteristics of the cities. On the two sides are not identical. In fact, the relay should not operate as the fault in the zone outside its protected zone. Percentage bias reference relay is used to overcome this difficulty. Okay. Next, difficulties in differential protection in transformer. The difficulty schemes describes suffers from the following drawbacks. First is on-load tap changing or ratio change as a result of tapping. Second is unmatched or mismatched characteristics of the CDs, magnetizing interest currents, and difference in pilot wire lengths. First is on-load tap changing or ratio change as the result of tapping. Generally, for a power transformer, tapping are provided on the winding. Depending on the load, we may change the tapping positions as the turns ratio may be changed. To compensate this effect by varying the tappings on differential protection cities is not practicable. Bias differential protect relay ensures stability with the amount of unbalance occurring at the extremes of the tap changes range. Bias relay are well suited for the overall protections of variable ratio transformers. Next, unmatched or mismatched characteristic of cities. The difference in CT characteristic due to the different ratio being required in circuits of different voltages may cause noticeable difference in the respective secondary currents whenever read through the fault occur. These problems is arised in case of transformer due to unequal ratio CTs being unemployed on either side of protected transformer. A source of ratio error which result in circulating current under through the fault conditions is the unequal when imposed on the CTs due to the load length. This difficulty can be overcome by using the bias differential relay. Third one is magnetizing interest current. Initially, when the transformer is energized, there is no induced EMF in it, and the conditions is switching similar of an inductor. Huge amount of interest current flow due to the low interest resistance relay. As the relay take it is an internal fault. This difficulty can be overcome by employing a percentage differential relay, incorporating a harmonic resistant relay. And fourth one is difference in pilot wire length. The equipment to be protected and the CTs are placed separately in the pilot wires. It is not possible to connect the relay coil at desired points. The difficulty is overcome by connecting adjustable resistors called balancing resistors in series with the help of the pilot wires. Now, protection against in magnetizing current, interest current in transformer. When the voltage is supplied to the transformer at the starting, huge amount of interest current flow through the primary winding of the transformer due to low resistance. This increased current is called magnetic interest current. The value of magnetizing interest current is much higher than that of the load current flowing in the primary winding. Will make differential protections to operate as it appears like an internal fault, which leads to unnecessary operation of the relay. The magnetizing interest current differs from the fault currents in the following aspects. First is, it is several times higher than the fault currents relay, nearly 8 to 30 times. It contains huge amount of second harmonic component because of the wave shape. Wave shape of this current is quite different from that of the fault current. A separate relay is used to magnetizing interest taped second harmonic components. No such type of relay is used for fault currents. It is an example of harmonic resistant relay. The protective scheme which protects the transformer against fault but does not operate in case of magnetizing interest current consists of high-speed percentage differential protections incorporating a harmonic resistant relay. It is also called as harmonic resistant differential relay. This type of relay is sensitive to fault current but remaining inappropriate to the magnetizing current. The relay provides protection against the magnetizing interest current. The initial primary winding current of transformers on no load, which may many things greater than the rated current. It consists of a series LC circuit which allow only fundamental harmonic components to flow through the operating coil and it diverts all higher harmonics and DC components path through the restraining coil. As the restraining coil receives rectified sum of fundamental and harmonic component, inrush current having a higher harmonic contents gives more restraining torque and relay remains inoperative to magnetizing current. Okay. So these are the harmonic resistance relay. Okay. Now, core balance type earth fault protection in transformers. The winding makes contact with the core when the insulation over the winding is damaged. The value of the leakage current produced due to this is less than that of the short circuit current. More damage results if its earth fault persists for longer durations. For this core balance type protections can be given in this figure. This is the primary and secondary winding and this is the current transformers. Okay. This is the core of current transformer. This is the secondary winding. Okay. And this is the primary winding is the transmission line. And this is the relay. This is the protection and this is the strip circuit contact. 3 wires of the primary winding are passed to the core of a current transformer. There is only one secondary winding on the core. The winding is connected to the relay. The vector sum of 3 currents passing through the 3 wires is 0 when there is no earth fault. So there is no resultant flux in the core. So no current flow through the secondary winding and hence there is no current flowing through the relay. But when the earth fault takes place, the vector sum of primary winding or primary current does not become 0. So the flux is produced in the core. As a result, current flow through the secondary winding and so the current flow through the relay coil and the relay will be operates. This type of protection does not give protection against overload, only protection of earth fault. So this is the core balance type earth fault protections in transformer. Okay. Thank you.